We will go through the solutions for the exercises. Let's go through the multiple choice. Number 1, the variable that you predict, this is your dependent variable, your y. Number 2, the graph that we use in simple regression analysis is known as scatter plot, B. For the regression equation, negative 3 as you can see is the slope and 21 will be your y-intercept. So in this case the correct one is negative 3, D. Number 4, we have a positive correlation between the two variables. The data go up from left to right, so the correct one is C. For number 5, R is known as the coefficient of correlation. The correct one is C. It takes values between negative 1 and 1, so the correct one is A. For number 7, R is given, R is 0.36, so the R square will be the square of 0.36, so the correct one will be C, not A. That's a very common mistake. You take the square of 0.36, not the square root. So this is equal to 0.13. The correct one is C. For problem 1, I will use the graphing calculator. So I will go to Stat again. I will go to Edit. As I told you before, if you have any data, click Delete. Now my y is 43468. Don't forget y is your L2. So it will be 4, 3, 4, 6. As you see, I made a mistake, so this is very common. 4 again, and then 6, and then 8, and then for the L1 we have 2, 1, 4, 3, and 5. Then we go to Stat, we go to Calc, and we go to number 4, and then we click Enter twice. So as you can see, the slope is 1 and the y-intercept B is 2. So your equation will be 1x plus 2. A is 1, B is 2. Predict the value of y when x is equal to 4. You can predict from 1 to 5. So you substitute x by 4. So in this case your y will be equal to 6. And then, as you can see, the third question is the coefficient of correlation. And from the graphing calculator we have the R, it's 0.7906, 0.791. That indicates kind of strong, not very strong, positive relationship between the two variables. In the same way we do problem number 2. We have the y, L2, we have the x. We enter the data in L2 and L1. So your slope is 2.543. The constant is 12.196. So this is your equation. You can predict y when x is 9. You can predict from 3 to 12. So in this case you substitute x by 9. So your y will be 35.083. Then the correlation of the coefficient of termination is 0.9986. And this is the explanation, and the correlation coefficient is 0.9993, almost perfect positive relationship. Now let's go to see problem number 3, and I will do also number 3 by using the graphing calculator. You go to Stat, you go to Edit, where you can eliminate your data, click Delete. And the same thing for the second variable. Now for this problem you have to figure out what is your L1 and L2. So you try to predict the revenues based on expenses. So expenses will be your X, revenue will be your Y. So revenue will be your Y because you try to predict it, and expenses is your X. X is the independent variable. So expenses we have 1, 2, 4, 6, 10, 14 and 20. And your Y will be 19, 32, 44, 52, 57, 60 and 70. Again, you must have the same number of X's and Y's, otherwise you cannot get the regression equation. Go to Stat, go to Calc, go to number 4, and this is going to be your equation. As you can see, the slope is 2.2893 and the constant is 29.0727. I use 3 decimals. Predict for 12,000, that means predict for 12 because it is in thousands of dollars. So you simply substitute X by 12. So this is 56.544 or $56,544. So these are the revenues when you have 12,000 of expenses, advertising expenses. The last part, R square, it is here 0.8239. So 82.39% of the variability of revenues is explained by the variability of expenses. The remaining 17.61% is unexplained. 17.61, you take the difference between 100% minus 82.39%. This is 17.61%.